Hello friends, today we will discuss the topic of metallurgy. I am Dr. P.R. Malle, Assistant Professor and Head, Department of Chemistry from Led Bhaskara Singh Arts, Professor Narendra Gonde Science and Ashalata Gawande Commerce College, Sakarkheda. We will start the metallurgy. Introduction. Metallurgy is defined as an art and science of getting the metal in the pure state form and ore. The science that deals with the procedures used in extracting metals from their ores, purifying and alloying metals, and creating useful objects from the metals is called as metallurgy. Ore is a mineral from which the metal can be extracted economically. Point to remember is that all the ores are minerals, but all the minerals are not ores. Thus, bauxite, calamine, and copper pyrites are some examples of. Now we will discuss the steps involved in metallurgy. Metallurgy involves various steps in the extraction of pure metals, from which their ores can be broadly classified as follows. Number 1, crushing and pulverization. Number 2, ore dressing or the concentration of ore. Number 3, calcination. Number 4, roasting. Number 5, smelting. And number 6, refining. So we will discuss them one by one. First we will talk about crushing and pulverization. Now what is crushing and pulverization? This occurs in the nature as the huge lumps as the big pieces. Thus, they are broken into small pieces with the help of crushers or grinders. The big lumps of an ore obtained from the mine are crushed to convert them into the smaller lumps and pulverized or powdered using a ball mill or the stamp mill. We can see it in the adjoining figure. You should be remember that the image which are taken here in the presentation are taken from the internet and these are used for representation purpose only. Now next step, ore dressing or the concentration of ore. These ores are usually obtained from the ground and therefore contain a large amount of unwanted impurities. The impurities like sand, earthy material are associated with metallic part. These are known as gangue or matrix and it is to be removed before further process. Thus, the process of removing gangue or matrix is called as concentration of ore. The entire process of concentration of ore is carried out by the following methods. Number 1, it is gravity separation. It is also called as hydraulic washing. In this process, the powdered ore is subjected to a stream of flowing water so that the lighter impurities flow away with water, leaving behind the heavy metallic particles. It is done by using the hydraulic crucifier. This method is used for the concentration of heavy oxides of ores like ores of lead, tin and iron. Now we will see the froth flotation process. The process is generally used for the sulfide ores. That is, the method is used for the concentration of sulfide ores. The method employs the mixture of water and pine oil which is made to agitate with the ore. It is based on the fact that the sulfide ore particles preferably stick to form the bubbles while the gangue particles are moistened by air. The mixture of water, ore and various reagent is agitated by blowing the air through it, resulting in the formation of froth or foam. We can see the details in the adjoining figure, and in which after the formation of the froth or foam, the sulfide ore particles stick to the bubbles and float at the surface and the gangue particle settles at the. Third method is electromagnetic separation. Electromagnetic separation is done especially in case of the hematite ore, whereby the powdered ore is dropped on the leather or brass conveyor belt which moves over the rollers. This method is used when the ore contains the magnetic impurities. For example, ore tin store contains a magnetic impurity of wolfram, that is FeWO4, and hence the concentration of this ore can be done by electromagnetic separation. We can see the adjoining figure, the separation of the iron particles. In this method, the crushed ore is allowed to pass on the rubber belt which is moving on the wheels. As ore comes nearer the magnetic wheel, the part of the magnetic part is attracted towards the wheel and falls below to form a heap, while the non-magnetic materials falls away from the wheel to form a separate heap. Now third, calcination. It is the process in which the ore is heated strongly in the absence of air below the melting point. The process can bring about the following changes. Number 1. Removal of moisture from the ores containing water crystallization. Decomposition of ores like carbonates of zinc and copper. Removal of organic matter if present, and removal of volatile impurities. The ore becomes porous. Next, roasting. It is the process in which the heating of the ore takes place in the presence of air below its melting point. It brings about the following changes, that is the conversion of ore into oxide and sulfide, removal of impurities like sulfur, arsenic and their volatile oxides. Thus the ore becomes. We will see smelting. It is the process in which the roasted calcined ore is heated to high temperature along with the reducing agent. It is the process of getting a metal by fusion from an ore. The process can be done in the following steps. It is done by mixing the metal with the reducing coke and flux, heating the mixture in the blast furnace to form the molten metal and the slag. In the adjoining figure, we can see the process in which the blast furnace is used. The slag, which is lighter than the molten metal, and therefore two layers are formed in the furnace, the upper layer of the slag and the lower layer of the molten metal. Thus the molten metal can be separated from the slag. Now we will see refining. The metal obtained by the smelting process is an impure metal, and thus it requires purification, and it is purified by the means of electrolytic refining to give almost 99.9% of pure metal. The process of refining is done in following steps. A suitable metal salt is used as an electrolyte. The blocks of impure metals are used as an anodes, and the thin sheets of pure metals are used as cathodes. Electrolysis is carried out. On electrolysis, pure metal gets deposited on the cathode, and the cathode plate becomes thicker while the anode plate becomes thinner, and therefore the impurities settle down at the bottom, which is known as the anode mode, and thus we get the pure metal, which is almost 99.9% pure. Thus, these are the different steps involved in metallurgy, and hope you should be very much familiar of the steps which are done during the extraction of the metal from an ore. So, thank you.